Hello students, now we are going to discuss the important application of equilibrium, how we can change the equilibrium towards product direction or towards the reactant direction, that means toward forward direction or towards backward direction. How can we get more amount of product, how can we get more amount of reactants for the particular reaction by changing the temperature, pressure, concentration, by adding catalyst or by adding inert gases. How can we change the equilibrium? But already we know for a particular equilibrium change, the equilibrium constant is always remains constant. It does not change with the change in the concentration, pressure, temperature, because it is almost constant for a particular reaction. But how the equilibrium will be shifted, how the equilibrium will be changed so that you can get the more amount of product or the more amount of reactant. This thing is very important application of that equilibrium, that is Le-Chatelier principle. This principle main responsible how can you bring the change in the direction of equilibrium, how can you get more amount of product or how can you get more amount of reactant by bringing the change in concentration, temperature, pressure, or by adding the catalyst like this. So today we will discuss how the system in equilibrium will be affected by changing the concentration, temperature, pressure of the system. But before that, you see the statement of Le-Chatelier principle. This is responsible to study the equilibrium, direction of equilibrium, shifting of equilibrium towards forward direction or backward direction, or there will be no change in equilibrium. We will discuss this thing. Here the statement is like this: whenever a system is subjected to change in concentration and pressure, temperature, catalyst and inert gas, if you bring the change of these things, then the equilibrium will be shifted to the direction, either forward direction or backward direction, to minimize the effect of change, to minimize. That means in which direction it will move so that it will adjust the change. Because equilibrium constant remains constant for a particular reaction, it will not be changed at all. Only it will be affected by the temperature. But for a particular system, it is equilibrium constant is remaining constant, no change in the value. But if we will change the temperature, pressure, concentration and other factors, the Q, that the K remaining constant, to bring the constant K, how the equilibrium will be shifted, how the equilibrium will be changed towards a particular direction, let us discuss. For this, already you know, for the law of chemical equilibrium, that for the reaction AA plus BB, equilibrium changes to CC plus BD. Then what is the expression of Kc? Kc is C to the power C into B to the power D upon A to the power A, then B to the power D. This is the expression of Kc, equilibrium constant. It is constant for the particular reaction. But if you bring the change in concentration of either reactant or product, if you bring the change in concentration of reactant or product, then Kc will be changed. For example, if you add more C and D, then the numerator value will be increased. If you add C and D, then this value will be, then whole value will be increased. If you add A and B, then the denominator will be increased, so Kc will be decreased. but Kc remaining constant. So the particular moment when you are bringing the change in the concentration or the temperature or pressure of the system, Kc remaining constant, but at the same time that change is observed, that is called Qc. That is called Qc. What is Qc? Qc is called reaction quotient. It is called reaction quotient. It is called the reaction quotient. It is continuously changing. It can be changed by changing temperature, pressure and concentration. But Kc remains constant. So when you are, for example, when you are more C and D, then Qc will be greater than Kc. If both C and D ratio is same, for example, if Qc is equal to Kc, if both are same, there is no increase or decrease of the concentration of product and reactant, then that is called equilibrium. This is the condition of equilibrium. Okay? But when Qc is greater than Qc is greater than Kc, that means this product value is more. This value when increases, then automatically Qc will be greater. It is always constant. If you add more and C and D, then Qc value will be more than Kc, because this factor will be greater than, that means it is this Qc will be greater than Kc. When Qc will be more, then Kc, to bring the same Kc value, so what happens? This Cd, increasing Cd will be consumed to give the product, to give the reactants. So when Cd will be increased in the system, then in the product side, then the Cd, increasing Cd will be again consumed to give the A and B, that means reactant. That's why equilibrium is shifted towards backward direction. So when Qc greater than Kc, shifting towards the backward direction. Backward direction. Why equilibrium shifting towards backward direction? Because when you increase C and D, then Cd, increase Cd value again consumed to give A and B, so that Kc remaining constant. Where it will be increased, then equilibrium shifted towards backward direction. Okay, when Qc greater than Kc, equilibrium shifted towards backward direction. You have to remember this is that is theory. Then third point, when Qc less than Kc, then this value is less. This value less means Cd value is decreased, or AB value is increased. When AB value will increase, then the increasing AB will be consumed, will be reacted each other, forming more C and D. That means equilibrium shifting towards forward direction. Qc less than Qc means shifting towards forward direction. Forward direction. So you have to remember these three things. When Qc, what is Qc? The reaction quotient, that is the actual value for the particular moment. When you bring the change of the system, then Qc when Kc, that is equilibrium. When Qc greater than Kc, this value is more, that means this value will be consumed to form the reactant. That's why Qc greater than Kc means towards backward direction. If Qc less than Kc, this value is less, then equilibrium shifting towards C and D, because it will give more C and D, so that it will minimize, to bring the change, to keep Kc constant. So how Kc will be constant, then the reactant and product will be changed accordingly. So this is the condition for that relation between Qc and Kc. Then what are the factors affecting the equilibrium? Factors affecting equilibrium. factors affecting equilibrium. First is concentration. Concentration already we know. When you bring the change in concentration, then QC will be changed, but KC always remain constant. So when reactant increases, reactant concentration increases. When reactant concentration increases, this value is increased. That means AB will be added, then equilibrium shifting towards forward direction to give more C and D, so that this ratio will remain constant. That's why reactant concentration increases means equilibrium shifting towards forward direction. Forward direction means more amount of product will be formed. When reactant decreases, reactant concentration decreases, then equilibrium, when this value will be decreased, then to adjust the concentration of A and B, C, D will be shifting towards A and B, so the ratio will remain constant. Reactant concentration decreases means backward direction. Okay. Then similarly, if product concentration increases, then equilibrium shifting towards, if this value is increasing, then it will be shifting towards backward direction. Then backward direction. Just opposite. If product concentration decreases, then it will move towards forward direction. Because this is a very simple concept. When the CD concentration increasing, shifting towards A and B. If AB concentration increasing, shifting towards C, and just opposite, so that to minimize the effect of change. So this is a very important factors affecting the concentration. Then the second factor is pressure. Pressure means we have to see the gaseous. Only pressure means consider only gaseous things. Gaseous reactant and product. Only gaseous reactant and product will be considered, because we know solid liquid will not be affected by pressure. So only gaseous product or reactant will be considered. So increase pressure. If pressure is increased, then equilibrium will be shifted towards. If pressure is increasing, then equilibrium will be shifted towards where? Less number of moles. Towards the side having less number of moles. Less number of moles of reactant or product. It depends upon the number. Increasing pressure always shifting towards less number of moles of reactant and product. Decrease in pressure will be shifting towards. If pressure is decreased, then equilibrium shifting towards more number. Just opposite, more number of moles of reactant or product. It depends upon the number. Okay. For example, let us take, suppose 2A, suppose this is G, convert to B. This is the one change. This is also B. If you increase the pressure, then here if you see which side number of moles are more, here number of moles are more in reactant side. Increased pressure will be helpful to shift the equilibrium towards forward direction, because forward direction has less number of what? Product. Number of molecules of product are less in right side, that is in product side. That's why by increasing pressure, because this side the number of moles are more, this side number of moles are less. When you increase the pressure, equilibrium will be shifted towards forward direction, you will get more amount of B. So 2A plus B, by increasing pressure, equilibrium will be shifted towards B, towards B means forward direction, because when the pressure is increased, as per the theory, equilibrium will be shifted towards less number of moles. You will see, compare this side 2 moles, this side 1 mole. As the pressure is more, where the number of moles are less, this towards this side, equilibrium will be shifting. That's why by increasing pressure, more amount of B will be formed, and by decreasing pressure means the side where number of molecules are more, so towards A, that means more amount of A will be formed by decreasing pressure. So this is the what? Effect of pressure, effect of concentration. Now we discuss the effect of temperature. Okay, you write down this one. Only you have to remember the theory. Which direction equilibrium will be shifted, by increasing or decreasing pressure, or by changing the concentration of reactant and product. Okay, is it completed? Complete it. Then effect of temperature. Effect of temperature mainly depends upon whether reaction is exothermic or endothermic. Here, what happens? Increasing temperature, equilibrium will be shifted towards endothermic direction. Increasing temperature towards endothermic direction. Maybe towards reactant or towards product, but you have to see which side endothermic change takes place. And decreasing temperature, equilibrium shifting towards exothermic direction. This is very important. For example, A changes to B, it is in equilibrium, forming B. Here delta S is equal to positive. Here positive value means endothermic. As the A changes to B in the forward direction is endothermic, but in backward direction is exothermic. But you see, A changes to B, delta S positive means it is endothermic towards forward direction. So this case, by increasing temperature, more B will be produced. Why more B will be produced? Because increasing temperature always affect towards endothermic direction. As A changes to B is endothermic, so more B will be formed. By decreasing temperature, equilibrium will be shifted towards, decreasing means towards exothermic, decreasing means towards exothermic, just opposite. So more air will be produced. So this is the theory. We have to see which direction the equilibrium will be shifted. Accordingly, you will get the amount of reactant or product. So, as the A changes to B is endothermic, so increasing temperature will move towards B. But decreasing temperature move towards A because B to A is exothermic. So, this is the very important explanation of effect of temperature. Then, fourth one is that catalyst, addition of catalyst. We know what is the role of catalyst. Catalyst always increases the rate without being used. Only it increases the rate. A changes to B. If you are catalyst, both rate, forward rate and backward rate, both will be increased simultaneously. A to B will be increased and B to A will increase, so that Kc remain constant. That means addition of catalyst has no effect on equilibrium. Why there is no effect of equilibrium by addition of catalyst? Because catalyst increases the rate forward direction and backward direction in the same way. At the same time, both reaction, forward direction and backward direction increases simultaneously. That's why there is no change in the equilibrium. It cannot move towards forward direction, it cannot move towards backward direction, because both forward and backward directions simultaneously increase in both directions. That's why there is no change in the equilibrium by addition of catalyst. Only what happens? It only helps to achieve the equilibrium fastly. Catalyst helps to achieve the equilibrium. Only it helps to achieve the equilibrium fastly. Only equilibrium will be achieved fastly by adding catalyst. But there is no shifting of equilibrium in a particular direction. That's why catalyst has no effect on the equilibrium. Okay. Then fifth effect is inert gas. Addition of inert gas. Addition of inert gas it depends upon the condition. Only remember this thing. Condition is like this. No effect at constant value. Inert gas has no effect on equilibrium at constant volume. When volume is constant, there will be no effect of equilibrium. There will be no change of equilibrium towards the particular direction. It will not be shifted. So, addition of inert gas, no effect at catalyst at constant volume. No effect of equilibrium at constant volume. Then second factor is very important, that at constant pressure, it will be shifting towards just opposite, towards what? Higher number of moles. It will be shifted towards more number of moles. At constant pressure, it will shift towards more number of moles. Towards more number of moles. So at constant pressure, it will be shifting towards more number of moles the reactant or product. Where the number of moles are more, it will be shifted. Just opposite of pressure. Pressure we know at high pressure, here pressure is constant. As the pressure is constant, then it will be mainly depends upon if you increase the volume. When the inert gas is added, if the volume is decreased, then equilibrium shifted towards more number of molecules. Just opposite. At constant pressure, if you add inert gas, then equilibrium will shifted towards more number of molecules. That side, the side containing more number of molecules, equilibrium will be shifted. Only that you have to remember. But if the inert gas is used at constant volume, if the volumes keep taking constant, if you keep the volume of the system remain constant, then there will be no effect of equilibrium. Okay? This is the very important factors affecting equilibrium, that is temperature, pressure, concentration, catalyst and inert gas. Let us discuss some examples. Example is like this. We can discuss. Suppose synthesis of ammonia. Nitrogen plus 3 molecules of hydrogen, then forming ammonia. All are gaseous product. Then here it is exothermic toward forward direction. Delta H is minus 92.4 kilojoule. So indicates it is exothermic towards. You have to know the nature of reaction, whether exothermic endothermic. As towards forward direction is exothermic. So first factor is by decreasing, as towards forward direction is what? Exothermic. So by decreasing temperature, equilibrium will be shifted towards forward direction. Towards forward direction. Towards forward direction means, what does that mean? More ammonia will be produced. So to get more ammonia, you have to decrease the temperature, because towards in the ammonia direction it is exothermic. So temperature should be less. This is the condition. So if by increasing temperature, if you increase the temperature, then equilibrium will be shifting towards what? Backward direction. So backward direction. For this example, for this reaction, this is the condition. Not this is the not condition that increasing temperature will be backward. No, this is the case. As the equation is exothermic towards forward direction, so get more ammonia, temperature should be decreased. To get more nitrogen, hydrogen, by increasing temperature, backward direction, equilibrium shifting towards backward. Backward means more nitrogen, hydrogen will be formed. That means ammonia will be dissociated. So by increasing temperature, ammonia can be dissociated. By decreasing temperature, ammonia can be synthesized. So this is the condition. Then third condition is, I can get more ammonia by changing pressure. Pressure you see. Suppose by increasing pressure. Increasing pressure. If pressure is increased, we have to see which side the number of molecules are less. Increasing pressure means, already we have discussed, increasing pressure means that number of moles are less. Which side number of moles are less? Here 4, 3 plus 1, 4, here 2. So increasing pressure, forward direction. Means more ammonia will be synthesized by increasing pressure. Okay? Then fourth point, by increasing concentration of hydrogen and nitrogen, then equilibrium will be shifted towards. If hydrogen nitrogen will be more added, increasing means more added, then equilibrium shifting towards opposite direction. If you take more this side, equilibrium shifted towards right side. If you take this side more, equilibrium shifted towards back side. So by increasing concentration of hydrogen nitrogen, forward direction. Forward direction means more ammonia or more ammonia will be formed if you take more hydrogen nitrogen. If you take more ammonia, then more nitrogen hydrogen will, because it is equilibrium. This is a very characteristic, important characteristic of equilibrium. You can change product to reactant or reactant to product by changing the condition. Different parameters if you change, then you can bring the change of the equilibrium. Okay, so this is the temperature effect, pressure effect. Okay, this is a very important thing. How can you increase? Question may be asked, how can you get more ammonia? What are the factors affecting? What are the conditions to get more ammonia? To get more ammonia, as it is exothermic, temperature should be decreased. As to get more ammonia, so more nitrogen, hydrogen will be added. Then, as this side is low, number of moles are less, number of moles are more. So this side is less number of moles, means by increasing pressure, equilibrium shifting towards ammonia side, so that more ammonia will be formed. So this is the techniques. Condition, definition, already statement, already we have read. The equilibrium will be shifted towards the direction to minimize the effect of change. So it will adjust the change. If one side is increasing, then it will be decreased by adding the others. So which side it will be shifting, it depends upon the condition. Okay. So if a reaction is, for example, another example you can take is the first example. Second example you take formation of that NO2. Formation of NO2. Let me take formation of NO2. That N2 plus O2 changes to 2NO. NO, both are gases. It is, this reaction is endothermic, plus the value is how much? 180.17. So this reaction indicates in the forward direction it is endothermic, because plus, as forward direction is endothermic, so how can you get more NO? Forward direction is endothermic means by increasing temperature first. So more NO will be forward, because what the forward direction is endothermic means if you increase the pressure, the equilibrium shifting towards forward direction. Then second, I can get more NO. Let us discuss that I can get more NO. So by increasing the concentration of N2 and O2, more NO will be formed. This is the condition. So by then another thing, third point, here just you see number of moles, this side also 2 and this side also 2. So by increasing or decreasing pressure, by increasing or decreasing pressure, what happens? If you increase the pressure or decrease the pressure, there is no change in equilibrium, no effect of equilibrium, because number of moles. This side also 2 and this side also 2. That's why as the number of moles are both sides are equal, so there will be no only gaseous. Only you have to consider gases. That's why there will be no effect of equilibrium either in forward direction or backward direction. There will be no change. So pressure has no effect in this reaction, but only temperature and concentration will affect. Then inert gas, catalyst, already we have discussed, catalyst has no effect on the equilibrium. Only inert gas at constant pressure will be affected, but at constant volume it has no effect. So this thing we have to see what are the condition, what are the nature of reaction, whether exothermic or endothermic, which side number of moles are more, which side number of moles are less. Then we have to apply the parameters so that we can increase the concentration of product, we can increase the concentration of reactant. Okay, so these are the application of that, some application of Le-Chatelier principle, but the Le-Chatelier principle can be used in your day-to-day life. Suppose for drying clothes, if when you move the wet cloths speedily so that it will be easily dry, the drying process will be very fast because the evaporation will be faster, so that the molecules from the cloth, water vapors from the cloth will be easily removed. So this is also application. You can if you take more sweet, so that it increases the decay of the teeth. The decaying of teeth process, the reaction methods will be very faster if you take sweet. That's why generally giving advice that don't take sweets, so that if they are taking more sweets, then their teeth will be easily decay. So that to control the teeth decay, we should take less amount of sweets, and our mouth should be washed properly, so that there will be no formation of acid in the mouth. So these are some important application of that in your day-to-day life. Already you know where we are using that washing machine for drying the clothes. When you put the clothes in the dryer, then dryer, the spin, due to rotation of the high spin, due to high spin of the rotator, it produces the vacuum on the surface of what happens on the surface of cloths. Due to this, there will be difference in the velocity, there will be difference in the pressure on the surface of cloths, so that from the cloths the vapors easily removed. So these are some application of that Le-Chatelier principle in your day-to-day life. So different types of questions will be asked in the application of Le-Chatelier principle. Only you have to remember what are the factors affecting equilibrium, whether towards forward direction or towards backward direction. We have to apply these factors in the shifting of equilibrium in the particular direction. Okay, thank you.